Okay, so this is chapter 5, which is the straight line stuff, y equals mx plus c. And a lot of it's from GCSE again, but it does go into some more depth later on. So let me just go run through some of the basic stuff. Starting off with getting an equation of a line from 2 points. So if you've got 2 points and you need to find the equation of the line through those points, you need to find the gradient between them. So in this case, it goes from 4 to 6, this one's on the left, so 6 to 4, which is minus 2, and then from minus 2 to 3, which is 5. You can draw a little sketch if you need to, so you can get the gradient. Then once you've got the gradient, you put it into y equals mx plus c. I know some people like to use the formula y minus y1 equals m brackets x minus x1. They're both going to get you to the same answer, which is this y equals minus 0.4x plus 5.2. You can always check that as well by putting in values of x and seeing if the y value comes out correct. It should be true for both of them. Yep, I'm just looking at those. So minus 2 times minus 0.4 would be 0.8 plus 5.2 is 6. So you can check that you've got the right equation. If you're given a gradient and a point, then you do the same sort of thing, but you don't have to work out the gradient first. It's given to you. You just put it into y equals mx plus c. The reason I bring this up is because it's very, very useful when we come to doing things with differentiation. A lot of the time you have to work out the gradient first using differentiation and then do this. So this is kind of a precursor skill, prerequisite skill that comes from chapter 5 or indeed from GCSE. With a couple of facts, parallel lines have the same gradient. So you'll see sometimes instead of y equals mx plus c, things will be written as ax plus by plus c equals 0. You can just rearrange that into y equals mx plus c to look at the gradient. Gradients of perpendicular lines, is that right? Yeah, are negative reciprocals. So what that means is if you multiply the gradients of 2 perpendicular lines, you get the answer minus 1. Some people like to think of it as like you turn it upside down and put a minus in front, or if it's got a minus, you take it away. That's also fine. But the way that you normally show that is by multiplying the 2 gradients together, and it equals minus 1, and that's your proof that they're perpendicular. You could also do some stuff with Pythagoras to show that 2 lines are perpendicular, but this is more simplistic. More stuff which is in the basic section is finding the length of a line segment. So a line segment is just a line that ends. It's called a line segment. So this line segment here between these 2 points is just using Pythagoras. You work out the length it goes across, the length it goes down, square them, add them together, square root. You've got the length of the line segment. So Pythagoras is very frequently used when you're doing something on a graph and you're asked about area or length. Finding intersections of lines is chapter 3. You solve them simultaneously, so either by elimination, substitution, or using your calculator. If you want to find when something intersects an axis, you just put the x equal to 0 if you want to find the y-intercept, and the y equal to 0 if you want to find the x-intercept. So y-axis is the line x equals 0. So it is solving simultaneously, but one of your lines is either x equals 0 for the y-axis and y equals 0 for the x-axis. They're the same thing, right? X equals 0 is the y-axis. I will point out a few things. Sometimes people get stuck on these kinds of basic things when algebra is given to them. So instead of giving a point like 3, 4 and minus 2, 6, which I think would be no problem doing, that's like GCSE, there's a value in there, there's like a k in there. So it'd be like 3k and then minus 2 brackets k plus 1 or something. If it ever does that, it will give you the gradient more often than not and ask you to show something about k. You just do the same thing. Difference in y, so 1 subtract the other, divided by difference in x. So just make sure you do them in the same order. So here I did 4 take away 6 to give me minus 2, and 3 take away minus 2 to give me 5. if you do that in the same order, like one point and then the next point, then more often than not, just normal algebra skills will get you from the gradient equation that you've just written to what you need to get to, which is normally a show that question, and they've given you the answer, you've just got to get there by using algebra. Normally it comes from doing that subtraction and that division and then just rearranging it. Same thing would happen up here if they tell you the length of the line and then you don't know one of the coordinates, or you know the length of the line because it's a radius or something from a circle. You can still do Pythagoras. You just say, I didn't know this coordinate was -3, but I did know that the length of the line was √89. You can still do that. You just kind of, you write 5 minus whatever, say they put that as A, you do 5 minus A instead of 8. You'd square it, and then you rearrange that to get the unknown. So in this case, the unknown is the line segment, but normally if they give you a letter, so something here is in algebra, they'll give you the length of the line segment. So you're just kind of working in the other direction. That can sometimes trip people up. But it's still the same skill. So if you know the length of the line segment, or if you know the gradient, you're still using the gradient equation and the Pythagoras equation. Intermediate skills then, there's only one, it's working out areas on a graph. So it's just kind of a combination of the previous skills. I've done some of this already, so if we were asked to work out the value of r, for example, we've got a line here, y equals 2x, and another line here, y equals -1/2 x plus 6. I've already put the 6 on. And we're asked to work out the area of this triangle. Then what we need to do is two things. We need to work out where that point is by solving this equal to 0. So that would be 12. And then we need to find the point of intersection here, because that's going to give us the height of the triangle. So if I were to put these equal to each other, 2x is -1/2 x plus 6, so 2.5 x is 6, and x is 2.4, 1.2, 2.4. Let me just check that. 6 divided by 2.5 is, 2.4. That gets me this one, 2.4. Y is 2x, so 4.8. And once you know this point, you can substitute into this equation. So this is just a triangle, and we know the base is 12, and we know the height is the y coordinate of the intersection. So more often than not, these questions are just these are actually a right angle triangle, isn't it? Because that's negative reciprocal. But more often than not, it's just half base times height. So in this case, what's that? 6 times 4.8 is 28.8. So similar skills, you notice it's finding an intersection by solving simultaneously. It's finding intersections with an axis by putting the x equal to, in this case the y equal to 0, finding what x would be. And then this is just the area of a triangle from GCSE, from year 7. So it's just recognising the skills you need to use, and it's more often not just these basic skills combined together. The thing which I put in as advanced skill is that basically anything to do with modelling is difficult, because it's all the skills but applied to a context, and you have to understand what the context is in order to get the marks. But they're normally quite simple mathematically. You just have to work out what it is the question's asking. So the things which come up are initial values. So what is the, if you get given a number in a modelling question or a part question, you're going to substitute that number in 9 times out of 10, or even maybe 10 times out of 10. But if you get given a number, you're probably going to substitute it in. If you ever get asked for an initial value, then that would be if this is a t-axis, the initial value is t equals 0. So you're just looking for the y-intercept. In this case, that's just 200. If you ever get a line like this and you know 2 coordinates on that line, you do this. Okay, work out the equation from those two points. Sometimes it's drawn for you, which makes it more obvious to spot. Sometimes it's written as 2 sentences. So it will say the value of one of the variables with the y-axis is whatever when p equals whatever. So we've written as a sentence, but it's just a coordinate written as a sentence. And then there'll be another one. So they just give you 2 coordinates, but they write them as sentences. When you do that, even if you just sketch a little diagram yourself, a little graph, you're going to end up working out the gradient, and then using y equals mx plus c, and the gradient, and one of those points to work out the equation for that line. Other things it talks about a lot of the time are limitations, so that comes up in almost every modelling question, limitations, and the obvious limitation for this graph is it's going to eventually go below 0, and most of the time for a modelling question, below 0 is just a no-go. So I haven't actually said what h and p are, it's because I couldn't think of a good example, but most of the time, if it goes below the axis, it doesn't make any sense. It could be, say, the cost of something. A negative cost doesn't make any sense. Again, if it's going up, that means it's going to continue going up forever. So as this one goes up, and eventually you've got infinity. And then normally that doesn't make sense. Normally there's some kind of limit to something going up. So if it's cost of something, then normally it gets limited. And if it's going down, then it tends to go into the negatives. And other than that, try and use the skills that you know of for straight lines and work out which one of them you need to use for the model. It is more tricky, you have to read the question carefully, but it's nothing extra for modelling. It's just the same things used in the context. Okay, that is it for straight lines. So, thanks.